So you guys will be given a relation, which is a set of ordered pairs. So here's our set of ordered pairs, 1, 5, 2, 3, 3, 2, 4, 2. Remember that an ordered pair always goes x, comma, y. Eventually you're going to have x, y, z. It'll be a three-dimensional graph, so that's how you can remember it goes in the order x, y. So for a table, you're going to have to make a table. You would have an x, y. Some people do it this way. All right, I usually draw mine vertically, but you can have a horizontal graph. Horizontal table, sorry. And so we just plug in our values. So our coordinates, we have a 1 with a 5, we have 2, 3, 3, 2, 4, 2. Okay, then you'll be asked to make a graph. I'm only going to use the positive side, so I'm going to make it like this, but I'm going to show that it's continuing. This is my x-axis, this is my y-axis. I don't have to number these because I'm assuming that if they're not numbered that it's counting by 1. So I need to go to 1, 5. 1 on the x, 5 on the y would be right here. Oops, 1, 2, 3, 4, 5, that's 1, 6, hang on. Okay, so 1, 5 is right here. 2, 3, 3, 2, 3, 2, 4, 2. Okay, so your graph should look something like that. Make sure we have our arrows on our graph to show. I don't like when people make a coordinate grid, they've been drawing a box around it. Do not do that because that's closing it in. It's like it's not going on forever. Now maps. Maps should be something you really haven't seen before. They kind of look like a pair of lungs, a student told me, and I agree. So for the x values, we write them all in here. 1, 2, 3, 4. Now you can't repeat a number. None of the x is repeated. But that's important. Do not repeat a number. Okay, so in the y values we have 5, 3, and 2, but I can't write the other two, the last two, because it would be repeating. So now we just map. We go from 1 to 5, we draw a line. The point 2, 3, then we have 3, 2, and we also have 4, 2, but I'm just going to draw it from the 4 to that same 2. That's why we do not repeat a number. So now we have domain and range. You're going to have to be able to find the domain and range of either a table of values or a relation, the set of ordered pairs. That's what a relation is, a set of ordered pairs. So domain are our x values. So what we would do is, since it's a set, we're going to list it like this. All of our x values, 1, 2, 3, 4. And the range would be the y values. You can remember this because D comes before R alphabetically and X comes before Y alphabetically, so that may help you. And our Y values are 5, 3, 2, and 2. I don't need to repeat the 2. So 5, 3, 2. You may also have to list domain and range of a graph. So when you look at the graph, notice that this is an intersection. It's an intersection, which we called an AND statement. So I know it's going to look like small number less than x less than big number from chapter 2. Okay, so the smallest of the x values is 0, and the largest of the x values is a 4. And it's going to be equal to due to the closed circles. So that's how I write my intersection for domain. And then for range, the smallest y value is 0, and the smallest the biggest y value, oops, I almost put an x there, it should be a y. The biggest y value would be a 1. So the y's range from 0 to 1, and it's equal to, again, due to the closed circles on the graph. In addition to finding domain and range, we also need to be able to identify if something is a function. In order to be a function, we want it to have no double domain. As soon as the domain repeats, it's not a function. Okay, so for a function to be possible, we'd have no double domain. All right, so I'm looking at my first graph, my first table here of values. My domain is 75, 68, 125. My range is 2 and 3. I don't write that repeated value because it's not necessary to write 2, 2, 3. Okay, so that's my domain and range. And if I look at my domain, let's highlight this here. If we look at the domain, there isn't one repeated number. And so this is a function. Okay, the next one, the map that's provided for us. My domain is 7, 9, 12, 15. My range, 7 is twice, sorry, 7, 7, 9, 12, 15. Make sure you see that. The 7 is going twice there. And my range is -7, -1, 0. So this one, there was a double in the domain. And we only care about the domain when determining if it's a function. And so this is not a function because of that double.